The Long Island Explorium is proud to present our STEM Wonder Lab, where we combine our live, hands-on, interactive STEM workshops and enhance them with the practical convenience of at-home learning. Using innovative STEM activities, with all materials needed mailed to you in advance. As part of this program, participants can ask questions of real-life scientists and experts about the month's topics. Join us for the next question in our series and sign up to participate and get your kit today.
How do light bulbs work?
Okay, that is another really good question. So let's talk about what the original light bulbs and what people usually mean when they think about a light bulb, which is something like this. So this is obviously a super tiny version, but if you say the word light bulb, it's probably something like this that springs to mind. So to work out how this lights up, what you need to do is zoom in really far. There we go. So can you see there is a tiny little wire inside there, that tiny little line? Just about see that? So that is called a filament. And what happens when you plug in a light bulb is basically an electric current flows through it. Okay, so to get an electric current, you will need one of these things or something similar. This is a battery. We need to connect up a complete circuit. So all I mean by that is basically give a route for the electricity to get all the way round in one continuous loop. So we could have battery connected by a wire to a light bulb and then connect that light bulb back to the other side of the battery. So you need to be able to go all the way round, like putting your finger along it and tracing it round without taking your finger off the circuit at any point. If there is a gap in that circuit, that means the light bulb is not going to light up, the current won't be able to flow, no good at all, okay? So that filament inside the light bulb is the bit that actually lights up when a current flows through it. But why is that the case? Why do normal wires not suddenly start glowing when we put an electric current through them? And it is all to do with what you might be able to guess, the fact that this is getting really hot inside there. So electric current always makes the things that it's flowing through heat up. You might have noticed if you leave something that is battery powered on for a very long time, then the batteries themselves get hot if you feel them after that. And that is because an electric current is flowing through those batteries and that causes them to heat up. So the same thing happens with this tiny wire, this filament inside here, when an electric current flows through it. So I thought I would prove to you that things do get really hot with a little visual demonstration of another tiny thin wire when an electric current passing through it. Okay, so what I have here is a set of 4 batteries that are connected in series. So if you connect them all end to end like that, that's called in series. The reason I'm using 4 batteries is you get a higher voltage when you connect them together in series. And I wanted to have quite a bit of voltage and therefore current to show you this demonstration. So just to prove that these batteries are working, here is my little light bulb that I was showing you earlier. So remember what I was saying about a complete circuit, having to have one continuous loop and trace your fingers around. So I'm going to go from one end of my batteries through this wire to the light bulb. Then I need to be able to trace this all the way around back to the start. So I can keep going round and round in a loop and we can see, ta-da, that it's working. We have light. Okay, so now I'm going to do the same thing to a bit of wire that looks more unusual. So this stuff here is wire wool. You can see each filament of it is a really thin bit of wire here. And we've just got a load of them together like this. Now, before I do this, like any good scientist, I am going to tie my hair back and I'm going to put my safety specs on. Because when you are doing experiments like this, that I've already told you are going to involve a bit of heat, better be safe. Okay, so let us do the same thing. So we're going to make a complete circuit. We're going to be able to trace it round through the wires, through our wire wool, back through this wire and back to here. So there is going to be a complete circuit and therefore the electric current will flow. So watch what happens when I make an electric current flow through this field. Okay. You see now why I put my safety specs on. Wow. So what happened there? Basically, as you put an electric current through that tiny thin bit of steel, it gets so hot because of the current passing through it that it literally catches on fire. So you might have noticed, once it caught on fire, I took away the wires. It was burning. It was going to carry on burning until it had all burnt out. Obviously, that's not what happens inside here. If every time we set our light bulb on fire, if every time we lit up our light bulb, it caught on fire, that would not be ideal. So the difference is, out here in the air, there is oxygen, and that means things can burn. Remember your fire triangle. We need oxygen in order for things to burn. Inside here, there is either a vacuum, or they fill it with an inert gas, which is basically something that a gas that won't let something burn, if that's the only thing that's surrounding it. So this filament here can't burn inside that bulb. The other thing that they do that is different is they have a material that this is made of. So it's obviously usually made of something called tungsten, which can heat up to an incredibly hot temperature before it does anything like melt or set on fire. So it is designed to be able to give out a lot of light without actually being on fire. Okay, so that is in essence how a filament light bulb works.